All right. Okay, so tomorrow is day 1 of your test. Tomorrow's mostly the chapter 5, 6 stuff that you're going to see on there. So we're going back a little ways into October when we covered these sections. Problems 1 through 9 on your packet are what you need to worry about for tomorrow, and then 10, 11, 12 are the hypothesis testing problems. That's what you guys are going to see on Thursday's portion of the test. So we're going to go through these 9 problems together, and then tonight you guys can work on a little Math Excel, finish that up if you haven't done that yet. I think that's due Wednesday night. Does that sound right? Yeah, and then you guys also have a practice test that's online that you can pick and choose problems from and practice those. Those solutions are posted for you also. All right, so you're going to get a basic calculator for all of this tomorrow. Starting with this one, it says the random variable x is normally distributed with a mean of 37 and a standard deviation of 3. Find the following and shade the area on the standard normal curve. All right, so what we're given here are x values. We need to convert them to a z-score first before we can find the probability on our z-chart. So you need the following formula. And again, you're going to be given all your formulas and your tables. X minus the mean divided by the standard deviation. So letter A, find my z-score. 36 is my x minus my mean 37. Divided by my standard deviation of 3. Then you could type that in the calculator. Here I'm just going to get negative 1 over 3. So I can do that one in my head. That's negative 1/3. Negative 0.33 is the z-score. Now, on your table, you're going to find the probability of z being less than negative 0.33. And the areas in our tables that we have all these probabilities are these areas less than, greater than, left, right. What are we given on this? These are always to the left, less than, which is what we want here, so we don't have to convert anything. So find negative 0.33, and you should see 0.3707. There we go. And then we want to sketch that. So remember, the mean is right in the middle of our normal curve there at the peak. And a z-score of negative 0.33 would be just to the left of it, maybe like there. And then we are finding the area less than, the probability less than, so that would be everything to the left of it that gets shaded. Okay. Any questions on the first one? Okay, second one. Here we have a probability of x greater than 31. So we're going to start the same way. Convert it to a z-score. 31 minus 37 over 3. That's going to be a negative 6 over 3. So again, this one I really don't need a calculator. I'm going to get a z-score of negative 2. So now the probability of z being greater than negative 2. What do I have to do with the number on my chart if it's greater than? Remember? You're going to have to do the complement. So 1 minus whatever the area to the left is, because 1 is the total area under the curve. All right, so negative 2.00 you're going to find in your chart. You guys should see 0.0228. And then we subtract. And I get 0.9772. Sketching that, again, mean would be right in the middle. Z-score of negative 2, 2 standard deviations to the left is going to be pretty far over. And then it's the probability greater than, which means we shade to the right. Remember, again, the total area under the curve is 1. So if you're seeing something like a probability of 0.97, that means most of it's going to be shaded. Okay. Last one, we're finding an area between, a probability between 2 values. So again, we're going to take both values and convert them to z-scores first. So 34 minus 37 over 3, which is going to give me a z-score of negative 1. 38 minus 37 over 3. gives me a z-score of positive 1/3. So that's going to be 0.33. All right, so now we're going to find the area to the left of each of those on our chart, and then we will, do you remember what we do with the values after we find both of them, if it's an area between or a probability between? I'm going to find both of them and then, good. Other one. Subtract them. You're going to find the difference between the two. You're going to do the larger one minus the smaller one we're about to do. All right, so 0.33 is 0.6293, and -1 is 0.1587. And again, just larger minus smaller will give you the difference, the area between. 6293 minus 1587, 0.4706 is going to be the probability, or the area between. All right, so -1, standard deviation to the left of my mean, 1/3 standard deviation to the right. It's not going to be quite as far to the right. And then my area is going to look something like that when I shade it. Okay. Mm-hmm.
So, for the -1, did we not have to? Oh wait, never mind.
Okay. Any other questions on problem number 1? No? Okay. Problem number 2. It says, in a recent year, the MCAT total scores are normally distributed with a mean of 500, a standard deviation of 10.6. Find the probability that a random selected student scored less than a 489. All right, so this is really the same as the previous problem. They're just putting it in real-world context here for you. Okay, so we have an x value. My x value is 489. They told us the mean. They told us the standard deviation. Convert it to a z-score. So 489 minus 500 divided by 10.6. And give it 2 decimal places, -1.04 is the z-score. So now we're going to find the probability that my z, again it says less than here, is less than -1.04. Find it on your chart. 0.1492. Okay. For the second one, find the probability that a randomly selected student scored more than a 514. Convert the 514 to a z-score over 10.6. When in doubt on your test tomorrow, just convert something to a z-score. It'll probably help. 1.32, and this time we're finding the probability that's more than that. Z is greater than 1.32, so we're going to do the complement of whatever we find on our chart. 1.32, 0.9066, and I get 0.0934. Okay, then it asks, are either of these events unusual? What do you think, yes or no? No. And there's 2 ways to explain it. The first way is probably with the probability. Do you remember what the magic number with the probabilities was if something was unusual? Yeah, the probabilities are both greater than 0.05. If either probability was less than 0.05, then it would be an unusual event. You can also look at the z-scores. Do you remember what the z-score magic number is for unusual? Oh. 2, -2. If it's more than 2 standard deviations from the mean, which both of our z-scores were not, -1 0.04 and 1.32. They're not more than 2 standard deviations from the mean, so they're not going to yield an unusual result then. So anything bigger than 2 or less than -2. But the probability is what this problem is asking for, so I would say that that would be the more reasonable explanation for this situation. Okay. Questions on 2? Okay, next up. Number 3, in a survey of women in the U.S. ages 20 to 29, the mean height was 64.2 with a standard deviation of 2.9 inches. What height represents the 95th percentile? Okay, so this is actually using the same formula we just used. The only difference is it's solved for x, and you guys can find it on your sheet. You guys can practice finding them on your sheet even if you want to. So where it says key formulas under chapter 5, the first formula that's on there is the z-score formula that we were just using, and the one right below it is transforming a z-score to an x value. And it looks like this: x equals the mean plus my z-score times the standard deviation. So it's the same formula, just a different variable that's alone, and then that's the one we're going to be using here. So you first need to find the z-score because we have the mean and the standard deviation, and then we're going to work backwards to figure out in this situation what x value that relates to. All right, so if you are in the 95th percentile, this is a review from a few chapters ago, that means that 95% of your data is below you. So what we're going to be looking for on our z-chart is the first area or the first probability that we can find that is greater than 0.95. Again, because 95% of the data needs to be below our number. Okay, so on your sheets, if your area is 0.95, you're looking at the positive z values, and you're going to find the first z value on here that is greater than 0.95. So you should find 0.9505 is the one that's closest to that, and that is the z-score 1.65. Okay. Then we're going to use that in our formula. So to get our x, our height, our mean, 64.2, plus our z-score, 1.65, times the standard deviation, 2.9. And then you type it in. I get 68.985, and that would be inches. And it doesn't say to round, so we're just going to leave it exact there. Okay. What height represents the third quartile? If you're at the third quartile, what percent of the data is below you? 75%. So it's similar to the last one. We're looking for the first area on our z-chart that we can find that is greater than 0.75. And that is 0.7517. So 0.68 is the z-score that goes with that guy. All right, so now convert it to an x value. 64.2, my mean, plus my z-score, times my standard deviation. And, oh, it would help if I typed in the right one. You should get 66.172 inches. Okay. Last one, what is the maximum height that would put us in the bottom 10%? So this time we're looking for anything below 10% because we want to be in the bottom 10%. So you're going to look in your negative side of your z-chart for that one. So that's going to be to the left of the mean. And you're looking for the closest value, but less than 10%, less than 0.10. So the closest I can get to that, but not go above it, is 0.0985, which is the z-score negative 1.29. All right.
So do you base it off like you're trying to see the number like greater or like less than if it's like the sign? Is that what you're looking for?
Yes. Okay. So percentiles, you're looking for something above it. Quartiles, you're looking for something above it. This one, it said bottom 10%, so we know we're looking for something below it. If it said upper 10%, we would be looking for something above. If it said upper 10%, we'd be looking for something above 90%. Okay, so yeah, it's just the way it's worded or what you're calculating there. All right, convert it to an x. 64.2 plus negative 1.29 times 2.9. 60.459 inches. Okay, questions on number 3. Okay, number 4. I realized in first period we are missing a piece of information here that is important. You need to know the standard deviation in this problem. So we're going to add one in. Let's make a standard deviation of, I don't know, just make up something, 5.2. Okay. So in this one it says you want to estimate with 95% confidence the population mean whose we eat fast food 4 to 6 times per week. Your estimate must be accurate within 3 units of the population mean. Assume the population is normally distributed. Find the minimum sample size needed. So this is our margin of error formula rearranged. It does say it on your formula sheet. Let me see what it's labeled as. It's under chapter 6. It says minimum sample size needed to estimate is what you're looking for here, okay? So it's our n value, which is our critical value of z times our standard deviation divided by the margin of error squared. That's the formula you guys are looking at for this one, okay? So we have a couple of these things already. Standard deviation I just gave you. What's the margin of error? The margin of error is 3. You want to be within, if you see that word, 3 units. That's giving you the margin of error. Your critical value of z, you're going to need to find on your z chart. Now, we were given that we want the confidence interval to be 95%, so we have a c value of 0.95. These critical values are at the bottom of your z-score chart where the negatives are at. I think yours are on the same place. So you're going to look for the critical value of 0.95 and find the z-score that goes along with it. The critical value of z is 1.96. There we go. Okay. So that's going to go in the numerator. And then we're going to square it. 1.96 times 5.2. Oops. Divided by 3 and squared. I get 11.54. Now, n is a sample size, so it can only be an integer, and we're looking for the minimum value. So right now it's telling me the minimum needs to be 11.54. I can't sample 11.54 people. So whatever number you get, even if it was like 11.001, you're going to round it up to the next integer, because if I round down, it's not enough. So n is 12 is going to be your final answer on that one. Okay. Questions on 4? Yes, ma'am.
Since the z is like 0.95,
Mm-hmm.
would it look for like the z critical value to start with that? I got confused. That's why.
So you see this on your chart where it says critical values in the bottom left.
Okay.
So you can look for it in the big chart, but these special values they've kind of pulled out for you already,
Okay. Now I see.
which is much, much faster than trying to locate it within the big chart.
What if they aren't on here on the chart?
They will be on there. You're welcome. Okay. Any other questions? Everybody finding everything okay? Yeah? All right. Okay, number 5, it says a school reports a confidence interval of the following when estimating the mean number of student drivers for the population of the student body. Find the sample mean and estimated margin of error. Okay, so if you have a confidence interval, where is the sample mean located in respect to the numbers that I see there? Where's my X bar? It is the mean, but how do I find it? It's the middle. Yep. So you can do midpoint. You can think of it like an average. Add them together. Divide by 2. All right. So 433.8 plus 572.4 divided by 2. 503.1 is my sample mean. The other thing we need is E, the estimated margin of error. So if I know the mean, the X bar value, my mean right in the middle, how do I find E now, the margin of error? Think about when you write a confidence interval. You take X bar and do what with E? You add and subtract it, right? So you just have to figure out what's been added or subtracted to get from X bar to either of those ends, and you can use different values to calculate it. I'm going to do the upper limit there, 572.4 minus the mean in the middle. You could also do the mean, take away the lower limit, and it's going to be the same distance. So 572.4 minus 503.1, and my margin of error is 69.3. Okay, questions on 5? All right, number 6, a machine is set to fill paint cans with a mean of 128 ounces and a standard deviation of 0.2 ounces. What is the probability that a randomly selected paint contains, it should say less than here, 127.9 ounces of paint? Okay, so this starts out similarly to what we did in problems 1 and 2. We have an X value. We're finding a probability. We're going to convert it into a Z-score first. So my Z, I'm going to take my value, 127.9, take away the mean I was given, 128, divided by the standard deviation, 0.2. 127.9 minus 128 divided by 0.2, get negative 0.5. There we go. All right, so because it says less than, finding the probability that Z is less than negative 0.5. So we're going to find negative 0.5 on our chart. And I get 0.3085. And because it's less than, there's no need to adjust that if at all it was greater than, like we did before, you would do 1 minus. All right, part B, you randomly now select 30 paint cans, not just one. What is the probability that they will contain a mean of, we should say less than again there, 127.9 ounces of paint? Okay, so we're going to find a Z-score again, but as soon as you have now a sample size, it's not just a single thing that you're calculating, we're going to be using the Z-score formula that we've been using with our hypothesis testing, where you divide by the standard deviation and also the square root of the sample size is included in the formula. So I'll write it out here. It's X minus the mean over the standard deviation divided by square root of n is what we're using. Okay, so it's got that extra divided by the square root of n in the denominator when we have a certain sample size that we're looking at a mean of. So it starts out the same way, 127.9 minus 128 divided by my standard deviation, 0.2 over the square root of 30. And again, give it 2 decimal places if you need to. I get negative 2.74. I give it a couple decimal places. So now the probability that Z is less than negative 2.74. Find it on your chart. 0.0031. Okay, and again, it said less than, so we want that area to the left. There's no need to adjust the value that we get. All right, so why in part B do I get a significantly smaller probability? Why in part B do I get a smaller probability? Why is that happening? Okay, so it has to do with the fact that we've got that sample size. In part A, it's just one randomly selected paint can that we're calculating the probability of. In part B, we're calculating the mean of 30 paint cans. So the likelihood that we're going to be less than the mean is smaller if we have a huge sample, because some are going to be below and some are going to be above, and really we're looking at the average of all of those values. So you need to be able to explain that in your own words, but that is the big idea here. In part A, it's the probability of one paint can, and in part B, we're taking 30 paint cans and averaging all of their ounces together. So the likelihood that it's below is significantly smaller than if I just look at a single paint can, okay? So part A is a paint can, part B is the mean of 30, and that's why we're getting a smaller probability of that happening. Any questions on that? All right. Number 7. We have some distribution charts here, and we are going to estimate just from the picture the mean and the standard deviation. Because you're estimating here, you're going to have like a range of numbers that you can give me that would get full credit. You don't have to have like the exact same number that I have here necessarily, but it should be close. All right. So when we're looking at something that is normally distributed, our normal curve, where is the mean located at? Right in the middle. So all you're going to do is take your peak, drop it down. All right, so if I take that first one, drop it down, what do you guys think maybe that looks like? 13. Okay, so we'll say X bar is 13. And then this, I'm going to use S here, sample standard deviation from this distribution. You're going to find what we call the inflection points, which is where it changes from concave down to concave up. So imagine like graphing a parabola that's coming down. At some point, that parabola that's opening down changes to a parabola that's opening up. And we're looking for where that kind of concave, that inflection point occurs. I'm going to guess it kind of sort of looks like maybe about where 20 is. If you look to the left of 20, that could kind of be a parabola opening down, and if you look to the right of 20, that could be like a parabola opening up. Okay, but again, we're approximating it there. So if that is my inflection point, how do I find the standard deviation then? Yeah, just subtract them. So 20 and 13 then would be a standard deviation of 7. And if you look on the other side, it should be approximately the same. Looks like maybe about at 6. So again, that would give me a difference of 7 there. Okay. But if you give me an answer probably between like 6 and 8 for standard deviation, I would give you full credit for it. Okay, so again, you've got like a range of numbers just because we're approximating. All right, let's look on the one at the right there. What do you guys think the X bar would be, the peak on that one? $22, $23? Something like that? Look good? 23? 24? You like 24? Sure. Okay. And then standard deviation, find that inflection point. I'm going to maybe like 30, 31. What do you guys think? 31? Okay, so if we say it's at 31, then my standard deviation would be about 7 again on that one. Okay. The one on the bottom left there, anybody see an issue with that? What's wrong with it? It's not a normal distribution. It's not a standard curve. So we cannot, from that distribution, estimate our mean and our standard deviation. We can use other things like central limit theorem and whatnot to make it one of those, but for right now, we don't have enough information to do that. It has to be a normal curve. Okay? Questions on that?
If we just put not possible for that bottom one, would that be?
Yeah. That'll be fine. All right, last two have to do with our confidence interval. So this one says a random sample of 64 dates. The mean record high daily temperature in Chicago area has a mean of 84.13 degrees Fahrenheit. Assume the population standard deviation is 14.56 degrees Fahrenheit. Find 90% confidence interval for the population mean. All right, so first of all, am I going to be using Z values or T values here? And how do you know?
Z, because it's, you have the population something.
Good. It tells us population standard deviation, which means we are going to use a Z for this. Now, it's a 90% confidence interval, 0.90. So again, from your chart, you can find at that very bottom corner there, the level of confidence that we're looking for, 90%. Go over to your critical value of Z, 1.645. To get off our chart. Okay. Other information we're given, what is 64? What variable is that? Not X on this one. N. And then the sample mean, 84.13. We're going to be estimating the population mean. And then the population standard deviation, 14.56. All right. So we have the sample mean. The next thing we need is our margin of error, our E formula. We're going to take our critical value, 1.645, and then we're going to multiply that by the standard deviation, 14.56, divided by the square root of n. So you can write that out if you want to. It's the critical value of Z times standard deviation divided by square root of n. If you were to use the t distribution, it's the same formula, except in the numerator, it's the sample standard deviation instead of the population standard deviation. All right, multiply them together. 1.645 times 14.56 divided by square root of 64. I get my margin of error is 2.99. Okay, so now to get my confidence interval for the population mean, we're going to take X bar, add and subtract on my margin of error, my standard error. So 84.13 plus and minus 2.99 gives me my confidence interval. Subtract to get the left number, add to get the one on the right. 81.14. 87.12. It's my 90% confidence interval. And then I don't think it says to say so here, but if you had to interpret it, you could say we can be 90% confident that the population mean is located between these two values.
How do you find the ZC if it's not like on the chart?
It will be on your chart.
What if it's not?
It will be on your chart.
What if we have the chart there, but how do you find it?
Okay, so pretty much if my interval is 90%, you're going to find, kind of like what we did with those areas in the earlier problems, you're going to find 90% on here, 0.90. And for this one, 0.90, where's it at? Oh wait, hold on. 90%. Wait, am I crazy? 1.645.
Yeah, I don't get that.
Oh, it's 5. Okay, so if you're 90% confident, there's 90% between your z-scores, which means there's 5% below and 5% above. So find 5% is how we did that. 0.05. And one of them is 0.0495 and the other is 0.0505. So they for this value, they use the one between them because it's between negative 1.65 and negative 1.64. They use negative 1.645. And you always use the positive value when you're looking at a critical value. So like, let's say it was a weird one, like a 92% confidence interval. It means 92% is between the values. So what percent is in each tail? You've got 8% left over, right? So 4 and 4. So I'd find 4% on here, 0.04, which that one's not exactly between, so you just use the one that you see that's closest. It would be negative 1.75. So you'd use positive 1.75 for the critical value. Make sense? Okay, but the test, it'll be your special ones. Okay, good for 8? All right. All right, last one, number 9. In a survey of 2,144 U.S. adults in a recent year, 746 say that mashed potatoes are their favorite side dish on Thanksgiving. Construct an 80% confidence interval and interpret the results. Okay, so for this one, this is not our one where we have any standard deviation that we started with. This is actually what we did at the very end last week. If you guys remember, we did like 6.3 and 7.4 all together. If you're looking for a formula for this margin of error, it's in chapter 6 in your formulas that are listed there. The first thing that we need to list is our N. Our N is our sample size. What's our sample size? Right, and this is a proportion problem. When we have a proportion problem, you're going to need a p hat. P hat was x over n. We have n, we need x. X is your number of successes, okay? In this case, it's people that would say yes to mashed potatoes are their favorite dish. So 746. 746 divided by 2,144. Is 0.348. Remember, give that a few decimal places. Make a big difference in your answers. Okay, margin of error formula to estimate the population proportion for these is a critical value of z times p hat, q hat, all over n under a radical. All right, so we're still missing a couple pieces of information. If I know p hat, how do I get q hat? Complement, 1 minus 0.348, 0.652. To get my critical value of z, we know that I want my confidence interval to be 80%. And that's, again, one that you've got on your chart there. 1.28 is my critical value of z. All right, plug it all in. 1.28 times the square root. P hat, 0.348. Q hat, 0.652. Over n, which was 2,144. Give this one a few decimal places. Remember, this is a percentage that we're getting out when we're estimating these proportions. 1.28 times the square root. Set up my fraction. Don't forget to use that. Times 0.652, 2,144. When you're using the basic red calculators tomorrow, you might want to do these in little pieces instead of trying to type it all in at once. You don't want to make a calculator mistake on these. Okay, so my margin of error is about 1.32% is what that means. So that's why I'm giving it 4 decimal places. So now to estimate P, which is the population proportion, we're going to take our P hat and add and subtract E, and that's going to give me my confidence interval. P hat, 0.348, plus and minus my margin of error, 0.0132, and you can write these as a decimal or a percentage. Either one's fine. If I subtract it, I get 0.3348 or 33.48%. If I add it, 36, almost wrote that one differently. Don't want to do that. 0.3612 or 36.12%. Okay. And that's your 80% confidence interval for the population proportion. So you could say with 80% confidence, we can say that the population proportion is within these two values. All right, and that is what you're going to see on tomorrow's part of the test. Okay, so you'll be given your formulas, you'll have a basic calculator, you'll have your standard table, all your critical values will be listed there, you won't have to find them. Okay, and then on tomorrow's test, Wednesday, we're going to be reviewing the last 3 problems on the study guide. It's all your hypothesis testing questions. You guys tonight can do some extra practice problems that are on Polaris. You can even, start with the hypothesis testing questions if you want. The bonus worksheet that I gave you on Friday is due Thursday this week. If you want to do that, I'm going to make that worth 3 bonus tickets on part 2 of your test. So if you're interested in doing that, just turn it into me by Thursday. And then Friday, when you walk into class, what do you need to have? 50 temperatures ready to go when you walk into my class on Friday. Okay, so you got a few more days to collect those if you haven't already. All right, I'll do our cell phone lotto and we are done for the day.